So most of 11.4 actually isn't anything new. It's just how quadratics show up in other formulas that a lot of them we dealt with. A couple new things at the very end. But here we've seen this before. If I have a rational equation, so rational equation, well, we clear them out just like we did before. We use fraction busters. Stupidest sounding thing ever, but the idea is we multiply by a least common denominator. Well, these denominators really have nothing in common. So this x and this x minus 1 are really two separate groups. So our least common denominator is going to be all three pieces. The 12, the x, and the x minus 1. So I'm going to multiply all three pieces by a 12x, x minus 1, 12x, x minus 1, and 12x, x minus 1, and start simplifying what we can. For instance, in the first one, the x cancels. In the second one, the whole group x minus 1 cancels. And in the last one, only the 12 cancels. So it gets a little complicated. You got to simplify this bugger. We've got 12 times x minus 1 is 12x minus 12. On this one, we're left with just, I think, a 12x. And on this one, we have, now really what I'm not left with is just x times x minus 1. I have a 7 and an x times x minus 1. So think of it as 7x, x minus 1. Make our life a little easier, so it's what, 7x squared, and that's minus 7x. I'm going to simplify this, 12x and 12x, so about 24x minus 12 is equal to 7x squared minus 7x. Let me just double check this. Everything looks good. So now what we have to do is we have to solve this. It's a quadratic equation again, which means I want it ax squared plus bx plus c all set equal to 0. So I'm going to move the 24x and add the 12 because I really want to keep that a, 7x squared, positive if I can. Minus, how about 31x plus 12. So how are we going to solve this? Well, if this factors, definitely would factor it. No way would I have to do this by completing the square unless I really wanted to, because that 7 is not even a 1, so I'd have to divide everything by 7. And then 31 over 7 is not even, so this would be a mess by completing the square. I could do it. Don't recommend it unless you have to. So kind of leaning towards a quadratic formula, but we should still check the factoring. The factoring would be a times c, 7 times 12 would be 84, and makes 31. Factors of 84. 1 and 84 obviously is not going to help us. 2 and 42. Not quite there. 3 goes in there though, doesn't it? 3 and 28. Well dang, I think I just found two things that multiply to make a positive 84 and combine to make negative 31. So if you didn't take the time to do that, you'd have to run this through the whole quadratic formula, do a lot more simplifying, but I'm going to go ahead and solve this by factoring. 0 is equal to 7x squared. We split the middle term. Negative 3x minus 28x. First two have 1 in common. I think just the x, leaving us with 7x minus 3. The second two, 28 and 12, are both divisible by 4. Since the leading coefficient is negative in that group, I would pull out a negative 4, leaving us with a positive 7x minus 3. If you're like, oh my gosh, I'm lost, this is way more complicated, then maybe the quadratic formula is a better choice for you. But we have done this before, we have factored before, and this will actually be kind of our quickest, cleanest form if you know how to factor really well. So they have a 7x minus 3 in common, and an x minus 4 not in common, setting each of those groups equal to 0. I get 7x is equal to 3, so that x is equal to 3/7, and x is equal to positive 4. So there's our two answers. X equals 4 and 3/7. Could you have run that through? X is equal to negative b, x is equal to negative 31, plus or minus the square root of negative 31 squared minus 4 times a times c, all divided by 2 times 7. Yep, and eventually you would get the answers 4 and 3/7, but there would be a lot more simplifying to doing that. So it's your choice. Pick what works, pick what's easiest for you. Both are right. Both are going to get you the same answer. Well, maybe. Do be careful, and I left this in there because I know I always forget it. When I have a rational equation, you have to remember we cannot divide by 0. So just double check our original equation, which is 1 over x plus 1 over x minus 1 equaled, was it 7 over 12? Would a 4 make any of those denominators 0? And the 12 doesn't even change, right? But the 4 is fine, so we're going to keep the 4. Does 3/7. Now you don't want to have to plug in 1 over 3/7 plus 1 over 3/7, but it actually is right. It will get you that answer. But the issue here is when it's rational, we cannot divide by 0. Would 3/7 be a 0? No. Would 3/7 minus 1 be a 0? No. Then both of these answers are still fine. But do be careful on these. You do need to check the maybes on a rational equation. You cannot divide by 0. Second, we've done radicals before. Isolate that radical. So we have 2x minus 1 is equal to the square root of x. We undo the radical. We undo a second exponent with a second power. 2x minus 1 squared is not 4x plus 1. You're like, no, it's 4x minus 1. Utter nonsense. Cut that crap out. It's 2x minus 1 times itself. Distribute that. You should get 4x squared minus 2x minus 2x is minus 4x plus 1. And the right one's nice and easy. So now we have, once again, a quadratic. I need this set equal to 0, which means I'm going to move the x this time, giving us 4x squared minus 3x plus 1. This is now ready to solve. First, can it factor? 4 times 1 is 4. To make a 3. Looks promising. 1 and 4. 1 positive, 4 negative. Well, shoot, then I'm going to solve this by factoring. 4x squared. I'm going to put the negative first, so minus 4x plus x plus 1. The first two have a 4x in common, leaving us with x minus 1. Something's off, I think, because these are both x plus 1, so they're not the same, are they? Multiplies, oh, that's why it didn't work up here. I'm going to use AC factoring, use it right. These don't multiply to make a positive 4. They have to be the same sign to multiply to make a positive 4. So 1 and 4 would have to be the same sign, or 2 and 2. This is not factorable. Bummer. It's all exciting, or saved myself a lot of work. Okay. 2. Would I use completing the square on this one? Is the A a 1? Is the B even? Then I wouldn't complete the square on this. I would go to my last resort, which is the quadratic formula. A is 4, b is negative 3, c is 1, so that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. X is equal to positive 3 plus or minus the square root of 9, is that minus 16, all over 8. Be careful, 4ac. X is equal to 3 plus or minus the square root of negative 7 over 8. I have to have made a mistake here. Give me a second. Freaking negative 5. You are like sitting there screaming at your screen, going, what the heck is this guy's problem? Alright, so, does this still work? Actually, it does this time, doesn't it? They could both be negative 1 and negative 4. So I'm going to save myself a lot of effort. Be careful with these, because obviously I'm showing you can make some mistakes. So 4x squared minus 1x minus 4x plus 1. These both have an x in common, leaving us with 4x minus 1. These both don't really have anything in common, but when the leading coefficient's negative, we pull it out, leaving it as 4x minus 1. So now these two groups have 4x minus 1 in common and x minus 1. Setting them equal to 0. On the first one, we're going to add the 1, so that 4x equals 1 over 4. On the second one, we're going to add 1, get x equals 1. Maybe, okay? Keep in mind, we were dealing with a rational equation. What does that mean? We cannot have a negative. Well, if I go back to this, we had 2x equals square root of x plus 1. Would either of these put a negative in there? No, they're both positive. But if I did get a negative answer, it would be extraneous and we would throw it out. So our answers are 1/4 and 1. Keep in mind, I'm sorry I made mistakes, but it's going to happen, and I don't edit them out because, well, first of all, hopefully you catch them as you're going. But second of all, I want you to know we all make mistakes, so don't. But I could have run this through negative b plus or minus the square root of negative b squared minus 4 times a times c, all divided by 2 times a, and eventually I would get to 1/4 and 1. But I'm telling you from my experience, people make more mistakes in the quadratic formula than if they know how to factor. So if it can be factored, I encourage that you factor it. If it is rational, check that you don't get a 0 in the denominator. If it's radical, check that you don't get a negative in the radical, because then that's not a real solution. Okay? We're also going to have some word questions. We've seen these before. It's a little more complicated, but not too bad. Boat is 12 miles per hour, so traveling 12 miles per hour in still water. It takes 1 hour and 4 minutes to go 6 miles upstream and return. Find the speed of the current. Okay, well, let's think about this. 12 miles per hour in still water, that's the speed of the boat. But first thing you have to recognize is that this is a dirt question. Distance equals rate times time. So I'm going to set up my table going upstream and downstream. I know that it goes 12 miles per hour in still water. We don't know the speed of the current. Going upstream means that I am fighting the current. So what happens to the rate? Well, I have the rate of the boat minus the rate of the stream. The stream slows me down, whatever its rate is. Going downstream, I have the speed of the boat plus the rate of the stream. The distance, well, they give that to us. What is the distance traveled? We go 6 miles upstream and return, so that means upstream we went 6 miles, downstream we went 6 miles. And then they give us an hour and 4 minutes. Now that's not cool because that's not even 1 unit, but 1 hour and 4 minutes would be the same thing as 60 minutes and 4 minutes. So how about 64 minutes? But what that is that's not the time it goes one way. That's the time it is to go there and back. That's a total time. That means we don't know either times, but we know that if I take the time upstream and I add the time downstream, it should total 64 minutes. So we don't know the time upstream or the time downstream, but we know that they total to 64. So this is one where it's not really handy to use 6 equals 12 minus s times t, 6 equals, so what you really want to do is, because I want to relate the times, I have a relationship with the times, so I want each of these equations in forms of t. What does t equal? We'll take this dirt equation up here and solve it for t. Well, isn't that just distance divided by rate? So that time is equal to distance divided by rate. So what is the time going upstream? Well, it's the distance, 6, over the rate, 12 minus s. What is the time it takes to go downstream? The distance, 6, divided by the rate, 12 plus s. So now I can take those two and add them. 6 over 12 minus s plus 6 over 12 plus s is equal to 64. And if I solve this, I can now solve for the speed of the current. I get that it's complicated, but this is just a good application where quadratics show up. This is not as hard as it seems. Try to set them up and then try to solve them. Okay? On these types of questions on the test, you would get credit for the setup, you would get credit for the solving. So if you mess up on the setup somewhere, just still try to solve it. Persevere through these. This one actually is not that bad once we go to solve it. So, the problem with this is we got a bunch of fractions. So let's bust them. What is our LCD? Well, neither of those denominators are the same, so it would just be 12 minus s times 12 plus s. So I'm going to multiply everything times 12 minus s, 12 plus s, 12 minus s, 12 plus s, 12 minus s, 12 plus s. First two aren't bad. The first one, the 12 minus s's cancel, leaving me with 6 times 12 is 72, plus 6s. Second one, the 12 plus s's cancel, leaving me with 72, minus 6s. The one on the right sucks, because I got it 64 times a whole mess. So I'm going to go ahead and just write that as 64 times, and I'm going to distribute this first. 12 times 12 is 144. I have minus 12s plus 12s, and minus s squared. This is middle, zeroes out. On the left side, we have 72 plus 6s minus 6s cancels out. Oh, so 72 plus 72, how about 144? Is equal to, on this thing, we got to distribute a 64. So 64 times 144, not in my head. Not this time. How about 9216? I'm sure we all knew that. Minus 64s squared. You're like, I thought you said this wasn't going to be bad. It isn't. And here's why. How many s's are there? There's no like ax squared plus b. I don't have to factor this. I don't have to run this through the quadratic formula. I can use inverse operations on this. I can subtract first. So 144 minus 9216 is negative 9072 is equal to negative 64s squared. I can simplify that by dividing both sides by the negative 64. And as a fraction, if you wanted it, I don't know if there's a quick way to do this, but I don't remember. Let's see. So 567 over 4. And then we'd have to square root this sucker and get that s is equal to plus or minus the square root of 567 over the square root of 4 or 2. This is not practical. First of all, we're dealing with the speed of the current. The speed of the current is not plus or minus. It would just be plus. So really, s is only equal to the square root of 567 over 2. But still, like, what's the speed of the current? That's not very helpful in that form, right? So what do? Well, we put it in our calculator. 567 over 4. If I square root that, it's about 11.91. So that is the speed of the current, 11.91. I don't think right now, because we converted everything. I'm not sure if that's miles per hour or minutes per hour, I'm not sure. But that would be our speed. Okay? This would be more practical if I'm launching something in space. Then I want to make sure that I have this the most accurate possible. This is the more practical understanding what our answer means. Okay? Those are tough. These last two are not. This is really the last thing, and it's really the only new thing. Each of these is quadratic in form. ax squared plus bx plus c equals 0. What we do, though, is when I have an x to the fourth, we have up to 4 answers here. So what we do is what's called u substitution. You take the middle term and you call it u. You're like, why would we ever do this? Just be patient. If u is x squared, then what is u squared? What is x squared squared? What is x squared times x squared? So why would we do this? Because now I can take that first x to the fourth and I can turn it into, I can take that x squared and turn it just into u. And now I see it's quadratic in form. I can factor this way easier than I could factor the top one. What multiplies to make u squared? About u times u. What multiplies to make 36? Combines to make 13. About 4 and 9. Both negative. Setting each of these equal to 0, u equals 4, and u equals 9. Now here's the only tricky part about u substitution. We don't care about u. I'm not trying to be insulting. What are we saying? We weren't solving for u. We were solving for x. So what you have to do is at the end, unsubstitute. Put the u back in. replace the x squared for the u so that I can solve for x. So when I square root both sides, I get x is equal to plus or minus 2. When I square root both sides, I get that x is equal to plus or minus 3. Be careful to get those plus or minus, because at the beginning, with an x to the fourth, there were up to 4 answers. Now this is not the only way to solve this, but this is actually the easiest way. For a lot of you, you're not loving this because you've not seen u before. But this is another option for this one. I don't recommend it. What was it? 36, right? Double check that. Okay, I can just treat it like it's quadratic and say what multiplies to make x to the fourth, what multiplies to make 36. Then I would have to, I could take each of these groups and set them equal to 0, or I could factor it further. What multiplies to make x squared, what multiplies to make the 4, what multiplies to make x squared, what multiplies to make the 9. And notice I end up with 4 answers. Positive 2, negative 2, positive 3, and negative 3. And I could see a good argument for this being maybe a little easier. But u substitution has its purposes. First of all, in this class, I'm going to give you an example right now where you really need to do this by u substitution. But later, we do this in calculus. Why do we use the u substitution? We take something that looks complicated and we turn it back into something simpler. We're introducing it now just in the idea of factoring and quadratics. But man, this will save our rears in calculus. So what do we do on this next one? Well, first of all, it's not in the right form. I need it set equal to 0. So I'm going to move the 2. So 5r plus 3 squared plus 9r plus 3 minus 2. I'm going to call this quadratic in form. Like, how the heck could you even dream to do that? Well, look, ax squared, isn't this a something squared plus b times something plus c equals 0? So it is quadratic in form. And this becomes a lot easier when we do what? We take that middle term, just like we did there, and we say r plus 3 is equal to what? U. Then what is r plus 3 squared? Well, that's just u squared. So what does that do for us? I can now write this as 5 u squared plus 9u minus 2 equals 0, which is factorable. I want to solve this. This is now a nice looking quadratic. Nothing all crazy anymore. So what's our AC? 5 times 2 is negative 10. Combined to make a 9. How about 1 and 10? The 10 is positive, the 1 is negative. So 5u squared minus 1 u plus 10u minus 2. The first two have 1 in common. Factoring out the u gives us 5u minus 1. Second two have a 5 in common, leaving us with 5u minus 1. So, in common we have 5u minus 1 times u plus 5 equals 0. I could solve these and say 5u minus 1 equals 0 and u plus 5 equals 0. Adding the 1, 5u equals 1, so that u is equal to 1/5, and subtracting 5u is equal to negative 5. So we're all done, right? Nope. For the last time here, I get to say what? Nobody's interested in you. We weren't solving for u, we were solving for r. So what do we have to do at the end? Well, what was u worth? Well, that sounds horrible, right? What was u worth? Well, u was worth r plus 3, so r plus 3 is equal to 1/5. You have to kind of unsubstitute at the end. R plus 3 is equal to -5. Subtracting 3, -15 plus 1, how about -14/5? And minusing 3 here, how about -8? This is way easier than if you try to distribute all this out and then try to solve it with the factoring at the end. The u substitution makes our lives much easier. These are just a couple examples. U substitution, crazy useful. Definitely in this course. We build on it in pre-calculus. Vital in calculus. So let's get used to it now. Let's get used to u.